I was watching a video about Dragon Age, as one does, when I heard something that piqued my interest.
Also be aware there's a memory leak bug which is unfixable.
So I spent some time digging into this, and whilst the issue has been fixed, it was fun to look into why. And instead of scripting up a normal video where I talk to myself in an empty room and try and remain coherent, I thought it would be fun to share this with the creator who gave me the idea, whilst also trying to remain coherent. So without further ado, introductions.
Hi, I'm Josh Strife. I work on YouTube and Twitch. I have a couple of YouTube channels. The main one is called Josh Strife, where I review MMORPG games, and I have a series called Worst MMO Ever, which is essentially exploring abandoned online worlds. My second channel is Josh Strife Plays, where I do modern reviews of retro games, where we look at older games through a more modern lens, and we see if they have held up to the gaming landscape of today.
And so I am, my name is Nathan Baggs. I also have a YouTube and Twitch channel. My main focus is on reverse engineering and low-level programming, specifically through the lens of video games. So I like looking at old school DRM techniques and what it takes to bypass them in the modern era. And more recently, I've been looking at game preservation. So old games that have just bit rot has set in and they no longer work on modern games. How can we reverse engineer them, debug them, and patch them to keep those games alive for not only original fans, but hopefully some new fans as well?
I think we probably have a huge amount of crossover between our two audiences, because I know for a fact that I watch your videos and I was fascinated by your reverse of A Bug's Life, the one that needed the CD to be in to play, and you were able to go into that. And recently the one where if you speak to a character in an RPG game, the game crashes because it was trying to call some strange strings from somewhere, and you're able to work out where the text was and where the cameras were moving from that. It's magic to me. It's absolutely magic, but it's phenomenal to see the inner workings of these games.
Yeah, Venetica. So that was a I guess as a little bit of a plug, a community suggestion on my Discord. Someone was like, "Hey, I used to play this as a kid and it doesn't work anymore." I was like, "Okay, well, let's spend some time and look through it." And obviously, it's nice to get some content out of it and share those ideas. But it was good fun, and I think part of what I really want to do is kind of showcase people that there's more to computers than a lot of people think, and kind of inspire people to maybe think a little bit more about the thing we use day to day and just kind of how they work under the hood. And games is obviously an excellent kind of vehicle to do that through.
Oh, absolutely. To me, programming, coding, it's just wizardry. You're tricking a rock into thinking by zapping it with electricity, and then you're using a load of ones and zeros to make graphics appear on my screen. I've got no idea how you do it at all. I enjoy it. I think it's great fun, but I have no idea how it works. And I think what inspired you to then message me was, I think you were watching one of my videos and I said something about a game having a memory leak, which was actually incorrect.
Oh, spoiler alert! But yes, I was actually I was watching your Dragon Age videos. Like, is it? Well, what's the title? Is it?
Oh, was it good? Was it good? Dragon Age?
Was it good? Yeah. I'm not. I played a few RPGs in my life. I played a lot of I guess like Fable. I guess is sort of that kind of genre of RPGs I really like from a kid. I played a little bit of Dragon Age when it came out, but I never really played a lot. But I was just watching it because I find your content very entertaining, and it was a game that I had some familiarity with. But yeah, you said you need to patch it to kind of hell and back to make it work, which is kind of always interesting. But then you said one thing, you're like, oh, there's an unfixable memory leak in it. And I was like, wow, now does that not sound like a challenge? So yeah, I bought the game on GOG, specifically on GOG, actually, because it's DRM free. So it's easier to kind of mess around with. They don't have any or less likely to have like the anti-debug and, the protections to stop you messing around with it, because it's just, there for people to enjoy. So yeah, I had a look around it. I did some research. I took some notes, and yeah, I came across some interesting things, and I thought it might be interesting to kind of share those with you, and we can, kind of go through, I guess, my process of how I sort of approach these kind of problems. I had to build some really interesting custom tooling for this, so I'll kind of show you how that works. And yeah, it's just a bit of a show and tell from, I guess, two British YouTubers who like to wear white shirts.
Absolutely. I'm fascinated by this, because whenever something doesn't work for me in the game and someone says, oh, it's this, I don't have the technical knowledge to complain about it or to argue back. And I'm willing to take someone's word when they say, oh, this is how it is and this is unfixable. I'll go, well, okay, I'll believe you. You know far more than me. I like how you mentioned that you got the DRM free one, as if that would have stopped you. As if that would have been a thing where you go, well, pack it up, lads, we can't go any further. You'd have broken in there straight away. But I'm fascinated to see what you've had to do, what you found out, and what I thought was an unfixable bug has been discovered.
Yeah, so let's go through it. So let me show you the issue first, or where it manifests itself, because I have undone one of the patches that you need to play this game. Because I guess spoiler alert, like the patch does fix it, this specific issue, but it's kind of interesting to know like why does it fix it, because it's a bit of a generic thing. And then we'll kind of dig into like what the actual issue is, why the specific patch fixes it, and then kind of what that means.
So would you like me to say to the people what the effect of it was and what I thought it was, or do we want to leave that?
Yeah, give us some backstory. Yeah.
So what it effectively is Dragon Age is a classic RPG made by the team that worked on, I believe, Baldur's Gate 1 and 2, and I think Neverwinter Nights after that. And it's about exploring around the world of Thedas and going on this epic quest. And of course, that means there's a large overworld, there's lots of dungeons, there's lots of locations. And every time you travel from an inside to an outside location, or you travel from one part of the world to another via an overworld map, there is a small loading screen. And the longer you keep the game running, the longer that loading screen gets consistently. It may only take 3 or 4 seconds to load inside to outside when you go into and out of a building within the first 5 minutes of gameplay, but by the time you've been playing the game for 4, 5, 6 hours, those loading screens are going on for 4 or 5 uninterrupted minutes of loading. And everyone kept saying to me, it's a memory leak bug, it simply keeps everything in memory all the time, you have to shut the game down to stop it, it's always been that way. But apparently, you've found something else.
Yeah, so that is kind of the thrust of it, but it's not necessarily a memory leak in like the traditional sense. It's actually kind of just very poorly optimized. But what we can do is we can kind of dig in to see why it's poorly optimized, and then we can talk a bit around like why it's actually a massive pain to fix without like probably going back and modifying the original source code and rebuilding it. It's not something that I could easily patch. But we'll get into that. So yeah, I played the game for a little bit. In fact, I played it for 49 minutes, which was not enough to get to the area that I was told this issue happens the most. So I went and found a saved file from someone else. One of my favorite characters, square. And the most important load is the 5 square load or 6 square load. You don't want any of the others. You definitely want this one. But this guy's played it for like 30 hours, so I think he's done the stuff. The lands meet is over. Sure, mate. Like I'll take your word for it. I don't. Like, I'm on fire.
It was a good lands meet. Definitely one of the best.
A shame I missed it. I got a load of stuff on the bottom. There's a bunch of characters. Like I got a rough idea of what the plot was going to be and stuff. But you're right. It's the key thing is moving between areas. So what's nice now is that I can access the whole map, which is the main thing that I needed to be able to do. Right. I didn't want to play until I could get to this specific place. Although maybe after 49 minutes, maybe I was only 10 minutes away. I don't actually know. But I was like, as much fun it was playing the game, I did actually need to make a little bit more progress, a little bit quicker. I don't know. I have absolutely zero emotional attachment to any of these characters. I don't know who they are, but I normally just pick these 3 randomly and off we go. And then Denerim.
That'll work. Pop over to Denerim, see what's going on.
This, I was told, is one of the busiest areas in the game in terms of just like the amount of stuff it has to render.
Yes, I believe it's one of the largest cities with the most NPCs walking around.
And NPCs is the interesting one, right? So what I'm going to do is this bug manifests itself. I was trying this earlier about 9 times out of 10. So that means it's not going to work probably about 5 times in a row. But let's see if we can. see if we can get there for it. But basically there's a graphical glitch, and I saw this graphical glitch when I was playing it, and that was the first breadcrumb that I started following. Because I was like, that's strange. Not happening yet. Obviously, it's not going to happen this time. Because why would it? Why would it the one time I want to show someone an issue? So what I might do, I might have to kill it and restart. Sometimes going into the pub and back. You're right. It's the transition between areas that seems to be like the core. I think this is going to crash, which is what I was expecting after I saw the graphical glitch, but I'll use some editing magic to make it look like it happened much quicker.
Mm-hmm. There it is. Which, of course, from someone who has just purchased the game, downloaded it, and wants to play it, is an incredibly annoying thing. We kind of expect, and I think from the console generation onwards, we expect games to simply work.
It's funny for me. I get frustrated when games don't crash.
This is too optimized.
Yeah, there's nothing for me to do here. There's no fun for me to have. Okay, right. I will try once more if this doesn't work. Otherwise, you might have to take my word for it.
Oh, I absolutely. From what I've seen that you can do, I believe you.
Well, this is not me doing anything. This is just me trying to run the game with the crash. Okay, a little bit disappointing. Not off to a great start. I'm gonna do one more loop round because it's like bunches of characters it kind of starts happening to, and once it happens to one, it happens to basically all of them. Because
Oh, so it
we'll
propagates
see why
outwards.
exactly. And we'll see why as we get through it. But I was really hoping I'd be able to kind of show you because it's quite funny. So frustrating. Right, if not, you might have to take my word for it, and I'll just splice in some footage.
That's fine. Yeah, just throw
when it
the
works.
throw the footage in.
I cannot believe that. Like literally consistently every time, except for obviously this time. But
I wonder if it's because Discord is running at the same time as well.
I do wonder. Yeah, maybe there's some. Maybe
So it
it's
turns out the way to
changed-
patch the game is to
It's-
also have a Discord video call going on at exactly the
is
same
to ring
time.
Josh. Very specifically.
I'll make myself available. We'll have a timeline going on. I'll have a little schedule where if you want to play Origins, just give me a call. I'll sit there and watch you.
But yeah, so basically I was like, well, this seems strange. So then I thought, well, I was going off this kind of concept that, it's a memory leak. So I thought I need to kind of start figuring out what this is. And then I looked at what the fix was that you actually have a screenshot in your video, by the way, of the Steam page that fixes this issue.
Oh, excellent.
So that's where I kind of started. So you had this page up. You and your sort of standing there with your green screen and your coffee mug were talking over this. So I found this page. So this basically the fix is called LAA. So I'll explain the computer jargon and then just stop me if any of this doesn't make any sense or you kind of or just fire out any questions. But Dragon Age is a 32-bit process, so it was written for the time of Windows before it was kind of 64-bit, or at least was prominent. And Windows on 32-bit will only give each process up to 2 gigabytes of memory. So it doesn't matter how much RAM you've got, each process can only access up to 2 gigabytes, okay? Which is a problem for a quite an intensive game that probably wants potentially more than that. Now, when you run your 32-bit process on 64-bit, so I guess like a modern version of Windows, it still only gives it the 2 gigabytes, okay? But what you can do is you can enable this thing called large address aware, which will then make Windows give it 4 gigabytes. So you effectively double the amount of memory that the game has access to, and that fixes a lot of these issues. Okay. So the question then I was like, well, why does it fix it? Like, is this leak going to is it a leak, and is this going to happen eventually more again later, or is this kind of fix some other underlying issue?
Yes, because if that was a leak and it effectively is running out of memory at 2 gigabytes, then giving it 4 doesn't necessarily fix the source. It just delays until you're going to notice it because you're giving it more memory.
Correct. Yeah. So I read a lot of forum posts and stuff, and there's still people are asking like, does Dragon Age still have a memory leak and all sort of stuff? And a lot of people are like, just enable LA and it fixes it. It doesn't fix the host of other issues, but this specific one it fixed. And then I enabled it. So there's a bunch of tools you can use. I used a tool called CFF Explorer. So this allows me to view I cannot make the font any bigger in this tool, by the way, so you'll just have to squint, I'm afraid. But this gives me a load of information about the actual executable file itself. And you can go, where is it? Characteristics here, and then you can click app can handle more than 2 gigabytes of address space. If you click that enables it, and GOG ships with that already selected. So I use this tool
brilliant.
to
So the Good Old Games version has fixed it by having that already enabled, even though it's a thing you can manually do. It's just saved everyone some time.
Effectively, yes, right. So there are tools. I think the people who build this particular tool also build a patcher tool, which will just go and find that little flips. It's like a 0 to 1, and all your memory issues go away for some subset of memory issues. So then I was like, okay, fine. Well, now I'm kind of interested. Like now I'm invested in this story. Like, why is that? Because like I guess a memory leak is where when you're writing a program, right, you need memory, right, to do calculations in and store stuff. And so you ask the operating system for some memory, and then you have that memory until you are done with it. But when you're done with it, you have to tell the operating system you are done with it and basically give it back. And if you forget to do that because you made a mistake in your program, that is a leak, right? That memory can never be reclaimed until the process dies. So if you're doing that in like a loop or over and over again, you keep allocating more memory and never get back. And that's how a memory leak kind of explodes outwards. So first thing I did was, and this is pretty low tech, I ran Process Explorer, right? Just Windows Process Explorer, and kept an eye on the memory usage. So I don't know if I can kind of side by side.
Okay, I can see where you're going with that.
Yeah, so I was like, this is not like super accurate because Windows does a lot of stuff under the hood to kind of make sure you've got enough memory. It can page stuff in and out disks, blah 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 blah. But like if there was a real leak, like happening over and over again, you would see this slowly tick up.
This is the low-level stuff that I think I would be able to do and be comfortable doing, simply running a program while at the same time running a relatively basic program that ships with Windows to see how the memory is looking. This is my level of expertise that we're comfortable at.
That's fine. Like, and this is where I start, right? This is literally what I started with. And then you see so this is the loading screen, as you said. So the memory starts ticking up, right? So it's gone up. And as you walk around this area, it does slowly increase as you look at more and more stuff. But like, it doesn't like, if you just stop and wait, like it doesn't keep ticking up and exploding. So I was like, this doesn't feel like a leak. This feels like something else. I mean, bear in mind, if you've only got 2 GB of memory, we're already up to half of that.
Yeah.
Do you know what I mean? Just loading into this one area. And, if you move back into other areas, you can see it drop down again. So there's some resource sort of handling going on, right? It's not just like holding everything indefinitely. It is doing something. Okay. What do you know about DirectX?
I know that it ships with every single video game I've ever played, and I know that all of those games are very happy to say downloading DirectX, installing DirectX as if I need it 100 times. I know that I think it was the system that eventually became the Xbox, which is why it became known as the Xbox. It was just DirectX within a kind of standalone console. But apart from that, I don't actually know what it does.
Okay, so DirectX is like a suite of APIs or things provided by Microsoft, but we'll talk just a bit about the 3D one because that's like DirectX 3D or whatever you want to call it, because that's the most like pertinent one here. Imagine, so you got a GPU, right? And there's different manufacturers of GPU, right? And they all have their own artisanal, bespoke way of kind of communicating with it, right? So like, it'll have its own way of, its own language that you need to speak to get the flashy colors on the screen, right?
Which is why some games work better with certain graphics cards and some games work better with other graphics cards.
Yes, but imagine if you're writing a game, you don't want to write in the language of every single manufacturer of card, because that sounds like a massive amount of work. And also, what do you do when like a new one comes out and you want to update it and stuff like that? So Microsoft kind of attempted to solve this problem by releasing this thing called DirectX, and that is like it's an interface, right? So you talk to DirectX in its language, right? So DirectX specifies how to draw things on the screen, and then you talk that. And then each graphics card manufacturer implements sort of the back end of DirectX in their unique, bespoke, artisanal language, which is why you have to install a driver. When you install a graphics card driver, you're basically telling Windows how your graphics card will interpret the DirectX calls.
Right. And as there are different versions of DirectX, I believe we're up to DirectX 11, 12. I think, at the minute, or 12?
Yeah.
And that's just going to be improvements and changes to how that effective translation between what DirectX sees coming in and what it sends going out.
Yes, effectively. Yeah. Each new version improves the spec, gives you access to more features, stuff like that. So Dragon Age is a DirectX game, okay, a DirectX 9, so it's pretty old, but it just talks DirectX 9, and then your graphics card understands that and then translates it. This is a super high level overview, right? But just into that. So now that I kind of know this is where I can start to think about, well, how is the game programmed? Like, how can I start having some influence over it? So let's have a look. So back to here. The reason I know this, right, is because, I don't know if you can see this, this game imports something called d3d9.dll. So DLL is just a shared blob of code. And in this sense, Windows ships with this. So in order to use DirectX 9, you just have to tell Windows, I want to use this DLL, and then it will give you access to all the functionality. And then when the game runs, it will go and find that DLL, okay, load it into your game for you, and then you talk to that, and then some clever magic happens where it then finds your driver, and then it does the translation layer, and eventually pixels become colors on your screen. But you're quite far away from that point at this sort of point in the process. This exists on your system, right? Let me find mine. Okay, so my System32 file. Everyone's heard of System32, and if they don't know what it does, this is where all your sort of system DLLs live, right? So this is where D3D9 DLL lives, right? And Windows knows that. Like, Windows knows about System32, okay? Like, you would hope so. So when it says, I need D3D9.dll, Windows will be like, oh, well, I'll go find it here and load it for you, okay? Now, there's a fascinating curio of Windows, right? And this has been in Windows for forever. When you write your program and say, I need d3d9.dll, Windows has to go and find that. The first thing it will do is it will look in the folder where the game is, the executable is, before it goes to the system, and that has precedence over the system ones.
So if it happens to find a file with the exact name it was looking for, it would simply run that file.
Correct. And that now isn't that an interesting plot twist?
Which means I think I can see where this might be going to.
Yes. So I have. So if you create a DLL, right, just write some code. Just write some code. Like if you write some code and build it, so it has the same kind of name and shape as the system one, Windows will happily load that first and give it precedence. Okay.
No matter what the code actually says, it will just think this is the right file, I'm going to do it.
It's pretty dumb. Computers just do what you tell them to do at the end of the day. Like computers are
Computers
pretty...
don't make mistakes, humans do.
Exactly, yeah. So what you can do is, if you've never written any code before, this is not a great place to start, okay? But what I've done is this is my special... This will become my d3d9.dll, okay? And it has some special runes in it for Windows which make it all work. But more importantly, what it does is it exposes a function, like some interface, that the game I know will call, okay? And if it loads my one first, it will load this. And then what I do is I then go and find the real one from System32, okay? And then pass through it. So I'm a proxy. I'm a man in the middle, whatever you want to call it. So the game will run as normal, but execution has to flow through me first. And that gives me opportunity to do kind of fun things.
And in theory, it only needs to call this once.
Yeah, like it just finds it at the beginning and loads it. So if I go... I pre-built all these different ones to show you, so hopefully we wouldn't have to faff around too much building code. So if I just drop this d3d9.dll in here, okay, and then I run the game, it should run as normal.
But we know that what it did was it found the file that you wrote because it looked in the game folder first, and then your file told it to go and find the actual file within the System32 folder.
Correct, yes. So, and then what my code also does is it says, when you start up, just write a little file, and there you go. So this is written a little file. So this proves to me that
proves that it definitely did go through your file first before it gets to that one.
And I've got my hooks in the game now. I can do basically whatever I want. Like the sky's the limit. Like my code is executing within the context of the game. So this kind of gives me an in. Do you know what I mean? So I can start having a think around it. So I was thinking, I kind of want to get a bit of a better idea of like what memory is being allocated. Like Process Explorer or File Explorer, whatever you call it, Windows Explorer, it's kind of okay. But it's not fine-grained enough to kind of see what is actually going on. So I then had to do a bunch of research of how DirectX 9 works, okay? And I'm definitely not an expert, but I learned a few things along the way. And I found that basically everything eventually calls this special function called end scene. So when the game wants to render a frame, like a single frame of the game, it calls begin scene, draw, end scene, okay? And at point end scene, like everything has been sent to DirectX, and then it can then go to the graphics card, and then that can prepare it to what's called flip it to the screen. So it actually appears on your monitor. Okay. Does that kind of make sense so far?
Yeah, absolutely.
Okay. So my thinking was there's no more drawing, no more rendering happening after end scene, right? For that frame. Like end scene is like the full stop at the end of the frame, right? So I thought if I give it a fake end scene, if I give it like a hooked end scene function, right? So if I get the game to call my end scene, and then I make sure I call the real one like I did the other, there's nothing to stop me injecting a few more draw calls into it and maybe manipulating like the graphics of the game as it's running, because I know nothing else is happening after that.
Which means that you would then be able to have a level of control and a level of power over what is rendered on top of what, or what is called where, or textures and maps and things like that.
So at this point, almost all that's been happening, all I can do is draw stuff on top of everything else. Do you know what I mean? Like all those commands have been, I can't, if I wanted to influence the commands as they were happening, I'd have to go a lot deeper. But because DirectX is it's a very well-known kind of like layout in memory, like the kind of things it gives you, it's not too difficult to go and find out where all these functions are in memory, and then I can go and say, like, rather than the address of this function you want to be calling here, I can replace that with mine, and then store
Okay.
the original and then proxy it. So let me give you a bit of a better demo, because I think this is a little bit more compelling of what I wanted to do. So now I have this overlay.
Okay.
So I've issued additional render calls at the end to render a new window, which I can put in whatever I want. I just put hello from the hook, right? And like this is, you can dock this around, you can move this around.
wow.
Like it's this graphical library is something called ImGUI. It's a third-party library which is designed quite almost specifically for this, like a debug UI. So you can kind of throw it into your game and quickly get some extra functionality. But so now
Would these be the kind of things that often exist within video games that developers are still using to create that, especially in PC games specifically, sometimes just get left in the folders, but they don't have immediate access for the regular players, which is why you can find things online saying to call up the debug menu, press this button, this button, this button, and then you get the developer console as well.
Yep, absolutely. So there's no reason why Dragon Age may have already had something like this originally, and then they were just a bit more diligent in stripping it out. I use this library, so again, a bit of a plug, but one of my current live stream project is I'm building an FPS from scratch. And I use this library for my like level editor and debug menu, so I can kind of tweak, like move lights around, change colors, move entities around, that kind of thing. So this is quite a well-known library, Dear GUI, and it's just super great for this. It's super it's like in terms of like code, it's really not it's not a lot. So
it's quite lightweight, which means it's not going to put a huge amount of extra strain onto any kind of CPU or GPU working on this.
Exactly. It's designed to be lightweight. It's designed for debug UIs and sort of hacking menus and that kind of thing. For anyone who is interested, I will release all the code I use for this open source afterwards. So if someone wants to go and have a dig around it, they can kind of go and see how it works. It's really like it's not loads and loads of code, but it is. Some of it is not particularly trivial. So anyway, so now we can get into this, right? So I was like, okay, what I want to do is I kind of want to start tracking memory, okay? And I was like, well, having to have is this the one I want? Having to have like File Explorer open or Windows Task Manager, whatever is open on the side, is a bit of a pain. So I was like, can I kind of bring all this into everything and start pulling out some metrics? So then I started expanding this a little bit. Is this the one I want to show? Or have I jumped straight to the good one? Okay, no, that's fine. So now this just tracks memory usage in a graph just within the game.
So you're using the hook to effectively inject the overlay that you've created, and then on that overlay, you've also added some additional information.
Yes, so I can render whatever I want in there, and this library just happens to have a graphing library. So I was like, well, I'll just take something so I can see the current number of megabytes used. This is roughly what we saw earlier, right? So again, it's not particularly indicative of maybe the problem, but it was a starting point and just got me kind of familiar with using this. So you see, as we load, this starts ticking up. The code that I have to write to do this has to allocate memory, has to ask for memory from the OS, right? And I didn't want that to interfere with any of my sort of investigation and get it conflated with what the game's doing. So when the game starts in my code, the first thing I do is I allocate a massive slab of memory, and then I just use that internally for all my stuff. And it also means the crash is a lot more likely to happen because I've really pinched that memory, like the free memory,
which means
down.
If I remember correctly, Dragon Age, because it was a 32-bit, was allocated 2 gigabytes.
Yeah.
And then the fix, if you will, simply gives it 4. Yeah. But what you have done is limit the amount that's going to be available to it, which means you're more likely to see the issues that having 2 gigabytes would cause.
Yes, and if I wanted to do, because I thought I was going to have to do some quite fine-grained like memory tracking, I didn't end up having to do that, but I thought if I did, I definitely don't want what I'm doing to kind of ruin those results. So at least I've got a big chunk of memory to do it. So what I wanted to then do was I wanted to then track a bunch of other like DirectX functions, right? So you can see here stuff like create texture and create vertex buffer. So there's the DirectX gives the program the ability to kind of effectively allocate memory on the GPU. It's like a texture or some triangle data or something like that. And I was like, oh, I wonder what those are doing as well. And there's not that many of them in DirectX 9. So then what I did was I hooked those and then put in a counter. So every time they were called, it would like increment the number, and every time it was released, I'd decrement the number. So I could kind of keep track of live.
So in theory, the number should be close to 0 because ideally you want it called and then goes away when it's no longer being used.
It should be roughly stable, right? So if there's like 100 textures live, then that should stay 100. Like if there's a leak in like the texture allocation, then I'd see that
tick up and up and up.
ticking up and up and up. I went a little bit extra on this one. There's now a lot more stuff going on. So that log file I was writing before is now appears here, so I didn't have to keep switching between the log file, and it's got some extra information here. And then I keep track of like the live textures and the live vertex buffers and stuff like that. So again, there's 41 textures just loaded just on this screen. So there's 41 bits of graphic memory that it's using. I don't know if that's a lot or not, but like it does get higher. So then this starts peaking up. So then there's about 600-700 textures in this camp area, right? It fluctuates a little bit, which means it's probably streaming stuff in and out. Like if it knows there's something behind me, it might be able to like reclaim that texture and use it for something in front of me. But it's pretty stable, right? Again, there's nothing. It's not like it's leaking textures. It's not like ticking up and up and up and up and up.
So it's adding and removing things on the fly, but this is still the expected behavior of not necessarily the best optimized program, but a program that is stable to run how it's running.
Yeah, exactly. Yeah, and then you'll see when we load into the town, like we go up to like 1500, and that goes about 1600 depending on what you're looking at. Again, not ticking up, not going wild, but
you do also have a flaming weapon enchantment, which is going to, of course, be adding the fire effect to it. And most of your mages are also casting aura spells or area of effects, so they've got effects going on around them as well.
Yes, which will be loading those textures potentially in and out. But what's interesting, I noticed, is that I ran this with the fix afterwards to kind of see it, and when you go into like the pub, there's obviously much less. There's far fewer textures, but it doesn't drop down that much. It keeps a lot of the outer ones like hot, so it's much quicker to load out.
So that's because the game knows that you're in a pub that's in the city, so they keep these city textures effectively readily accessible.
Exactly, yeah. So, but it normally crashes when you go into the pub because of like the underlying issues. So I I played around with this for a bit, and I was like, oh, I think we crashed. Not what I was expecting. There are other issues afoot here, in the fact that I'm kind of probably hoovering up all of the memory. Let me just kill this. But there's kind of one interesting thing here, I think, that I wanted to kind of go through. One other metric that I started to analyze, and this ultimately is what kind of led me down to the conclusion I've got. And I've no idea if I'm 100% right, because I've never seen the source code. You know what I mean? I've not looked at it, but this is kind of my intuition based on sort of semi-careful measurements and a little bit of intuition. So what I've done here is I've kind of I'm logging like current, but it's a slightly different current to the other one. This is the total like what they call it, the virtual address space. So it's the every bit of memory has a unique address, right? From 0 up to however the maximum you've got, and this basically just tracks the amount of virtual space that is just available, so the amount that's kind of been handed out, and it's kind of there's not a lot left. There's 158 meg left, like 158 possible addresses of megabytes of addresses that could be given to the process,
which is not in a complicated video game that many left.
No, so we're already running up quite close. Bear in mind, I have allocated a large chunk of that for myself, so that's not necessarily the issue. What I think is interesting is I also track the largest contiguous free amount of space. So out of all that space that we could possibly have, 2 gig, the largest space in that is 15 meg.
So you couldn't put a texture or a single thing that was larger than 15 megabytes
yes.
in. Okay.
What a great intuition, because that is basically the problem. The problem is that the game's allocator it's either not well optimized or just not ready for this level of stress, but the heap, like the memory it's got is basically like a Swiss cheese. I think there's lots of space. I think it's in lots of very small gaps.
Which means that instead of being able to load one massive detailed texture, it could, in theory, load 10 to 15 much smaller, much less detailed textures and slot them into those gaps.
If the game is smart enough to be able to make that decision.
Okay.
As I will show in a minute, it is not, and there is genuinely a bug in their code that I found, but fixing it doesn't really help, if that makes sense. We'll get into that in a minute. So yeah, basically what I noticed is that as this largest free space got down lower and lower, the chance of crashing gets higher. Because, and I was like,
is attempting to put something that is larger than the amount of single space it has left into one of those spaces.
Yes. So yeah, I played around with this. I think I managed to get it down to 3 meg as the smallest gap. Was my record, because then it became a game to me. My game was seeing how much I could Swiss cheese the memory, and it definitely happens. Like the more you look, right, the more you kind of have loaded in.
Because the game really needs to load the skyboxes and needs to load the particle effects from the chimneys. It needs to load all of the little bits and bobs from the alleyways that you see.
Yes, yeah, and this never really this largest free block never really ticks back up. It kind of just stays fragmented.
So one thing that immediately jumps into my mind, and I'm going to be showing my age here, is we used to have to run the manual defragmentation software on computers, where you would see almost a visual representation of little tiny bits and blocks changing from color to color to color. Is that because, and I never thought about this, memory space does need to be as big as it can possibly be in one chunk, as opposed to lots of small chunks all over the place, if you want to load one big thing?
Yeah, if you've got like a spinning platter, right, which is what those old hard drives were, then you had to give it time to kind of move everything around to kind of reallocate. The SSDs don't really have that problem because it's totally different tech, right? But yeah, defragmenting is the idea that you should kind of remove those fragmentations. It doesn't really work.
Tidy all the data up and squish it together so you have a bigger open space.
Yeah, it doesn't work so well with memory because things rely on things being in the same place they were when they last looked at them. Yes. If you're like, okay, we're just going to squash all this down, then your code will be like, well, I was expecting this to be here.
Because it doesn't know which bit it's looking for. Okay.
Exactly, yeah. So more, I guess, modern languages with things like what's called like a garbage collector have a whole bunch of code in the game. In the runtime, which will do that for you, but there's a performance penalty for that. Whereas most games are written in like C++ or like a native language where you are expected to do all the memory management yourself, which gives you full control to just really squeeze the last sort of cycles out of your program at the increased risk of making mistakes and bugs. So everything's a trade-off, right?
Yeah.
But Unity games are all in like C# managed language, so they don't. I mean, it's not impossible to make a memory leak in it, but they have a whole bunch of systems that kind of come with the game that manage a lot of this memory for you. So
there are many MMORPGs that I've played on the main channel that do have what I think I would describe as memory leaks, that when you play them for more than 4 or 5 hours, the game will effectively slow down to the point of almost crashing. I even contacted one of the companies that make the game and said, is there a solution to this? And their solution genuinely is turn the graphics down.
Yeah, because it'll allocate less memory, right?
Yeah.
So I'm not an expert in DirectX 9, but when I looked at like the flags that it uses to create the texture, these are also backed by system memory. So whenever it puts something on the graphics card, it keeps a copy of it in the CPU accessible RAM as well, which is why creating the textures also increases the RAM usage. Because if you just put it on the graphics card memory, then it'd be like, why is this happening? But it's just, I'm not an expert in this era of graphics APIs. That is just an option you could pass to. I think they call it managed. I didn't look at it any more than that. I was like satisfied enough that was why the memory was going up with these texture allocations. What I did was I hooked the create texture function. Okay, so again, this kind of just passes through to the real one. But what I did was I logged the return code from calling that create texture. So when you asked DirectX to create texture for you, I was saying, can you just tell me what the result of that was?
And when we say create texture, we mean when you look at a model in the game, what graphic does it effectively put onto it?
Yeah, when the game's like, I need to display this, I need to create this in the GPU. This is effectively uploading or giving you access to some GPU memory, effectively. And I was like, okay, so what's this doing? And after a while, what I found was, and I don't think it's happening right now, but I will I'll do some YouTube editing magic to make this happen. Eventually, it was coming back with out of memory. So at some point, you were asking for textures, and the DirectX, effectively Windows, or the graphics card via Windows, was saying, I do not have enough memory to do this operation.
But it wasn't that the graphics card that you were running it from was actually out of memory.
But because it's backed by CPU memory, and I only had access to 2 GB of that on that
That's
side,
what's filling up.
That's what's filling up. Okay. This pool option. Don't know what it is. Not sure I care. But yeah, so I was like, oh well, that's interesting. So eventually this was happening, and then what I did was I put a breakpoint, so the ability for me to kind of stop the program as it's running on that line of code when it returned that error. So basically what that means was when the game was running and it hit this out of memory, it would stop, and then it would allow me to inspect the state of the program at that point.
So in theory, you could also, whether this is relevant or not, see the last texture it attempted to call or load.
Yes, but also more importantly, I can see who was asking for that texture.
Okay.
So I was like, because I think is it the Aurora engine that this was built on?
Yes.
I think I found that somewhere. Yeah. So I was like, okay, somewhere in the engine, something has triggered the need to create this texture. So basically, what happened is that I then I dug into and found like who was calling this. Okay, and this is, I think, is the really interesting part. So this is hopefully the last super technical thing I need to show you, and it is quite small. I'll see if I can make this a bit bigger. So games are just ones and zeros, right? Okay, but writing ones and zeros sounds like an absolute nightmare. So then they came out with this thing called assembly, which was like text mnemonics, which represented like known ones and zeros, which did things. And turns out writing that is an absolute nightmare. So then they invented programming languages, right? So then they invented programming languages, and then one of the most popular ones for this kind of stuff is C++. And so you write your C++ code, or your entire team spends how many years having lots of fun, I assume, or not, under miserable crunch time, writing all this code, and then that gets turned into the assembly. Okay, that's kind of like a one-way trip. Going back from the assembly to the code someone wrote is not trivial. Just because of the optimizations and the translations and everything that kind of goes through on the way. The compiler, the program that does this translation, it will more than happily rewrite your code, rip out bits that don't make any, that aren't called, unroll stuff, compress stuff, whatever, to make it as fast as possible. So the actual instructions that end up getting written can often be quite different to the code you wrote, even though they are functionally the same.
Okay, so it is still, in theory, possible to do. It would just be a huge amount of work to go back.
Yes, you can only do it heuristically, okay? And so there are these tools called decompilers, which will heuristically look at the assembly and do pattern matching against kind of like known compiler outputs and sort of other sort of control flow mechanisms, and attempt to give you something that looks like some code that someone may have written that would produce that.
So there's the input from the original writing of it, and then there's the output of what that now looks like. But there's not easily a direct kind of translation between one to the other if you didn't know what was originally written and then what was created. So from a developer point of view, it's doing the thing you want it to do. And from a player point of view, it's playing the way that it should play, but it's not necessarily a direct one-to-one cipher to transfer one thing to another.
Yeah, exactly. Yeah. So there's this free tool. There's several of them, paid, free, etc. So I use this one called Ghidra. It's developed by the NSA, but it's free to use, and it does heuristically takes that assembly and turns it back into something that looks like some code. And this is what it produced. This is what it thinks code is, and no one in their right mind would ever write code like this. This is a psychopath would write code like this, but it helps at least me get some idea of like the structure of the code and maybe what the original intent was. So this miserable thing here with all the astricize, all the stars, is that call to create texture. And I just, a bit of intuition, a bit of like prior knowledge. I just know that 0x5c bytes in from this address is the call to create texture. Sorry if that's a load of mumbo jumbo, but like I know that this is the call to create texture. And this is in the game, right? We're peering now inside the guts of Dragon Age, right? This is the code that gets run when we're playing. Like this is the code that's running right now. Nowhere does this code ever check the return value for create texture. The game always assumes it will get a texture. Hello, editor Nathan here. As I was cutting this up, I noticed that I'd made a mistake. The engine code does handle the error, just in a way that I wasn't expecting. I wanted to raise this for two reasons. Reason the first, this stuff is hard, and although I've been doing it for a while, I still make mistakes. Reason the second is that it's disingenuous for me to say the developers have a bug when they didn't. Regardless, the outcome is still the same. When the engine cannot allocate a texture, it gets in a weird state and the textures start flickering, which is a symptom of the highly fragmented memory. Anyway. Yes, yeah, and it's undefined behavior. Like, you have no idea what's going to happen, and I didn't like trace through the lifetime of that texture in the engine to find out specifically what, because I felt like I knew enough at this point to kind of understand the problem. And this is why it's still like borderline unfixable, because I'd have to trace through everywhere where this texture kind of then ends up and then rewrite that probably in assembly or patch out the assembly to do something else, because after it's created the texture, that's just like the create texture actually in DirectX 9 is just reserving space on the GPU. At some point later, it's going to try and copy from disk the actual texture into the GPU. So I'd have to find all that and, you know, like handle all that, because like if you know if you give it a default texture, it could be a different size. Like it's just like it's a whole thing. And yeah, and I think on the flip side, the other fix would be to gut out all their allocator code and maybe try and write one that was fragmented less. And I mean, what a nightmare that is, because everything in the game is going to allocate, and I have no idea what horrors they were doing to, you know, make it even this. Like, I know it doesn't. I know people say it's not optimal, but like they would have done some optimization work on it. Like a lot of work would have gone in to get this to run, and like who knows what kind of horrors lie beneath the surface to even get it working as well as it did.
Yeah, we're only seeing the bits that were either missed or left over, or potentially at the time it may not have even been tested on systems that would get to, you know, needing that amount of memory, needing that amount of graphics.
Exactly, yeah. And like I've got like, you know, if you lowered the texture size and everything, then you're taking less memory. You're gonna fragment the heap less. There's lots of stuff you could kind of do.
So it seems that, and again, this is me dumbing it down, very simple YouTuber talk. The code that was running was allocating an amount of memory to go and put a texture into that memory.
Yes.
And instead of saying, hey, if you don't find the texture that you need, don't worry about allocating the memory, it was just continuing to leave that allocated there so textures could be added to it.
Yeah. Yes. Yeah. So, Anne, can you see here these guys flickering? Yeah, that's what I was trying to show you. So they flicker because they've at this point, and I traced this back several times. As soon as it starts flickering, as soon as I start seeing the log messages saying error, I couldn't do it. So who knows what it's doing? It's just happened to have found another texture.
Which means as you are turning the camera around, and we are getting back to those ideas of draw this frame, every time it draws the new frame, it potentially finds a new texture to add to that model.
Exactly. Yeah, that's why. Look, you see, sometimes it gets this weird like default like white glowy texture as well.
So we're seeing it cycle through various clothes, various maps, various ideas.
Everything. Yeah, exactly.
Anything
sometimes even the normal maps change.
Load as a texture.
Yeah,
it is potentially adding onto that model.
Yes, so I will definitely include this clip in the video, because this is what I wanted to show you. But yeah, that's like I don't know if that's satisfying or not. Like, there's nothing to do with fixing it. Oh yeah, it goes really mad inside.
That's incredible. The fact that it's obviously you've got the normal map and the textures for the interior.
Yeah, but this is the only time it happens on static
colors
geometry.
Or textures to it.
Yeah, and it's messed up the blending of the fire particles in the fireplace. I don't know if you saw that. So it does like a lot. So
that's fascinating. So it's just about the memory allocation to the textures on the models.
Yeah. That's. I mean, I think I best set expectation. I think there are other issues in this game.
Oh yeah, it's not only that. There's going to be lots of stuff going on, but what you've managed to find is memory allocation for textures.
Yes, yeah. And there might be other memory leaks. This is not definitive proof that there is no memory leaks in Dragon Age. Like, this is just that under these specific circumstances that I was looking at, given everything I found.
Oh yeah, absence of evidence is not evidence of absence, as they say. You can't prove that it's not there, but we can at least say that this is doing this.
Yes, and I think if people are interested in like kind of like say going under the hood a little bit and just kind of figuring out a little bit about what's going on, like this is quite an interesting journey to go on, right? Like, you know, I had to build a lot of custom tooling. I had to kind of do a little bit of reverse engineering. I had to, you know, it's science at a certain point. You make hypotheses and you test it and you prove it, right?
Yeah.
Any questions? Because this is kind of the end of my show and tell.
No, not at all. Thank you so much for bringing me along to see this and explaining what I'm looking at, and for making all the videos so everyone that's interested in either computer science or video games can see how these things work, because it is ultimately just a load of ones and zeros that we have managed to translate, and we create those ones and zeros by writing various levels of various languages of code, and stuff will go wrong. And working out how stuff goes wrong is sometimes difficult to reverse engineer because you can't just look at a string of ones and zeros. You have to look at the code, you have to look at the writing, and sometimes that doesn't directly correlate with what's actually there. And it's solving a massive puzzle.
I really like puzzles, and this is I say this a lot. Like, the fun for me is not the game. The fun for me is figuring out why the game is doing something it shouldn't do, and then fixing it. But it is just a puzzle, right? Like, there's other bugs I fix in other games, and it's just this, but in various different guises, right? Of just grinding away, like layer by layer, until you kind of find a root cause, and then sometimes you can fix it. And sometimes, in this case, no offense to the Dragon Age community, I don't think me spending more time trying to do all those fixes I said would add any more to...
Oh, no. If we can just add more memory, especially we're at the point now where technology, adding an extra 2 gigabytes of memory is super simple. That's way easier than having to rewrite all the code to do this. We can just brute force this by saying, give it more resources.
And that doesn't mean, like, after a really extended play, the memory doesn't fragment again. I didn't really play it for like massive amount of hours on end.
At that point, just save your game, turn it off, and then reload it. I mean, anyone playing for 6 hours needs to at some point save the game, go and do something else for a bit, and then come back to it. And I say that as someone who plays games like that.
How long have you been playing World of Warcraft for today?
I'm trying to go for about 8 hours a day, and I've been averaging 8 hours a day for the last month.
Yeah, I'm personally more interested in bugs that are like absolutely game breaking, like a crash or a soft lock or something like that, rather than quality of life improvements. Because what I found is, for a lot of these games I look at, there's already an incredible community of people who are like working their asses off to patch and fix and figure these things out. And, you know, I'm absolutely not going to come and try and steal their glory or anything like that. You know, I'm very thankful to these people who spend their time doing this. What I hope I can kind of add is, like, if there's a really gnarly problem, or even an obscure game which doesn't have this massive community behind it, that's where I think I can add a bit of value. But kind of my goal for the video, like specific for YouTube videos, is they're not tutorials. They are, and I hate the term, but they are edutainment. Do you know what I mean? They kind of tell a story.
Yeah, that's exactly what it is. It's a fascinating deep dive into how something works, why it works, and people are fascinated about seeing what effectively is digital archaeology. That's what this is. This digital archaeology is digital biology, which sounds so strange to say, but the idea of taking the guts of something that is mechanical and digital and working out what's going wrong is fascinating.
Yeah, no, I think, and what I hope is that kind of inspire people to, you know, have a go at themselves. Like, obviously, I've got years and years of experience of doing this, so going from nothing, never writing a line of code, to doing what we saw today is maybe not feasible, but there's definitely like steps you can take to get there, and like there's so much interesting stuff you can kind of learn along the way, and that's what I hope to kind of inspire people to, you know, have a go at.
Well, this has been absolutely incredible. Thank you genuinely so much for taking a video that I made about a game that I enjoyed, seeing an issue with it, and deciding to get to the bottom of this for, honestly, the entire gaming community. This has been incredible.
No, and thank you so much for coming along and sparing some of your time to kind of go through it. It's really nice to kind of talk it out in a much more natural tone rather than like writing a script and filming it and recording it. It's kind of a little bit more organic. As is always the case with tech demos, it didn't maybe always go 100%, but we'll definitely it'll come out, it'll wash out in the edit.